Hello guys, and welcome back to chemistry class. And of course, we are continuing our episodes on gas law and kinetic theory of matter. We have seen Boyle's laws, we have seen Charles law, we have seen pressure law. Now we're going to be looking at today course chemistry, but we are going to be looking at the ideal gas equation. All right. So this is a very, very simple part of kinetic theory of matter and gas laws. And of course, the first thing you need to know is that gases can be described in terms of four variables. Gases can be described in terms of four variables, and of course, you know them. The first one is pressure, represented by P. Another one is volume, represented by V. There's another one called temperature, represented by T. And the fourth one is the amount of gas, represented by what? By N. Right? So I'll go back again. I said gases can be described in terms of four variables, which is what? Pressure, letter P, volume, V, temperature, T, and amount of gas, N. Please, before I continue, do know that this video tutorial is brought to you by O3Schools JAMB CBT Practice app. It is the best CBT app for exam success, for JAMB exam success. Let me be very specific, because the app also has what is WAEC version for WAEC exam success also. All right, so it has all the past questions that you need for your exam. It has wonderful features. There's an exam mode on the app, there's a practice mode on the app, there's a mock mode on the app, right? There are so many modes on the app, right, that you can use to study for your exam preparation. All right, what is even more fun is that there's a UTME challenge weekly on the app where you compete with other JAMB students to win prizes. But winning prizes is not the main reason why we do that challenge. It's for you to gauge your preparedness for the exam. So once you take a challenge, right, you see your score after the challenge. So you see the areas where you are weak, or where you need more seriousness on. All right, so once you see your score, you see your weakness, and you know how to improve on it. You know where to focus your strength on. So right, you are taking 4 subjects, for example, physics, chemistry, mathematics, English you score 90, maths you score 70, in chemistry you score 21, in physics you score 64. You should know that chemistry is your weak point, and of course you need to work on it, or you need to work on chemistry. So you need to focus your energy on chemistry more. Reading the other subjects is not as if you are not going to study them. You are going to study them, but you are going to focus your energy on chemistry. This is what the challenge will help you to do. So winning prizes is not the main purpose, but of course, if you are exceptional, you are going to win prize every week till your JAMB exam. So please take on the app, go to Play Store. It's being displayed on the screen right now. Go to Play Store, download the app, and of course, practice, and keep on studying. And you see that the sky is your starting point. All right, so let's continue. Like I've said, gases can be described in terms of 4 variables: pressure P, volume V, temperature T, and amount of gas N. All right, but of course, there are 5 relationships. There are 5 relationships between these variables, between pairs of these variables, in which 2 of the pairs, right, are allowed to change, while the other 2 are held constant. Right, there are other relationship between these variables where 2 are allowed to change and 2 are allowed to remain constant. And of course, we have seen some of them before. The first one is between pressure and volume, right, where temperature and amount of gas is held constant. This is the first one, right? And of course, in this one, we say it is it is Boyle's law. If you remember very well, if you have not watched the episode on Boyle's law, please go back and watch it. Do not skip any episode on JAMB chemistry. Please go back and watch JAMB chemistry. And of course, there's another one between pressure directly proportional to temperature. This is called volume and amount of gas held constant. This is called the Amontos law or the pressure law. All right. Then of course there's another one where what the volume is directly proportional to the what, to the temperature, and of course this one now with what, pressure and amount of gas held constant. And of course this is one we call Charles law. There's also another one, number 4, where what, volume is directly proportional to the what, amount of gas with what, with pressure and temperature held constant. And this one is called the Avogadro hypothesis. All right. So I said there are what? There are other relationships. All right. There are other relationships between pairs of what? These variables, in which two were allowed to change, while two were allowed to be what? Constant. So I've seen this first one, pressure and volume. In Boyle's law, pressure inversely proportional to volume, and temperature allowed to be temperature and amount of gas to be what? Constant, which was Boyle's law. We have seen between pressure and temperature, where volume and amount of gas is held constant, pressure law. We have seen volume and temperature, where pressure and amount of gas is held constant. That was Charles law. We have seen volume and what? And amount of gas, where pressure and temperature were allowed to be constant, and that is Avogadro's what, hypothesis. All right. So this relationship is a special case. Each of this relationship, each of this one you are seeing, 1, 2, 3, 4, each of them is a special case of a more general relationship, called the ideal gas equation. Ideal gas equation. All right. In the ideal gas equation, right, we have that what, that PV. We have that PV is equal to nRT. All right. In the ideal gas equation, we said that what, PV is equal to what, N and it's RT. Pressure multiplied by the volume is equal to the product of what, amount of gas, the what, the ideal gas constant, and the temperature. All right. So now let's see it clearly. Let's see it what, clearly, and draw some points, because this is where examiners get students down. All right. In the ideal gas equation, so examiners can easily get you down here. All right. So I say in the ideal gas equation, PV is equal to what, nRT. All right. So this is the ideal gas equation. All right. So there are some variables here that I may not be too so much conversant with if you are following our episodes. And of course, that is one will be what? Will be R. And the other one will be what? Will be N. You know, N is amount of gas. Now, you know, N is amount of gas. R is what? Is a proportionality constant. Proportionality constant. Called the what? The ideal gas constant. Ideal gas constant. All right. So R there is what? It's a proportionality constant that is called what? The ideal gas constant. All right. Then the T, of course, is temperature. T is what? Is the absolute temperature. All right. So this is important. You need to know this too. So R is the proportionality constant, or what that is called the ideal gas constant. Then T is the absolute what, temperature. Having known this, what else is there to know? The value of R. The value of R depends on the value of the other 4 variables. The value of R depends on the value of P, V, N, and T. You get? So before we continue, please give this video a like. A like means that for other students like you will easily find this video. And if it is helping you, it means it will help them. Please just click on the like button below this video. And then, of course, if you have not clicked on that red subscribe button, it means that whenever we publish a new video, you will not be aware. But if you want to be aware, if you want to be notified when we release a new video, just click on that subscribe button right now. And immediately you click on that subscribe button below this video, whenever we publish a new video, you'll be notified that we have published a new video. You are not paying for subscription. Subscription for this channel is free. Just click on the red subscribe button, and that is all. And then do not forget to share to your classmates, your friends, and to your class groups. All right. And of course, and we'll see you at the top. So let's get back to what we're talking about. So I have said that what the value of R depends on the value of P, V, N, and T. Let's go. So the value of R is equal to 0.0821 or 8.314. Now, I will let you know when it's 0.0821 and when it is 8.314. When are you going to use it? Because you are going to use them in calculation. How do you know which one to use? Right? I did not write their unit for some reason because I want to bring it out for you to see why we use what? We use a particular unit. All right. And then of course the example, the question we're going to treat, we're going to see how we can easily know how examiners want to catch us in question. All right. So the value of R is 0.0821 if the value of P, pressure, is in ATM, the value of V, volume, is in DMQ, the value of what? N is in what? Moles, and then the value of what? Temperature is in what? Is in Kelvin. K. All right. So now let's see. We know from ideal gas equation that PV is equal to nRT. That means that R is equal to what now? PV over what? Over NT. Right? So what is P? P here is what? P is 1 ATM times what is volume? Volume is what? 22.4 DMQ. Right? Now, every gas occupies a volume of 22.4 DMQ at STP. Right, that is the amount of gas. That's the amount of that's the volume occupied by any gas at standard temperature and pressure. That's why rising 22.4 DMQ. All right. So now over what is N? 1 mole. Then times what is temperature? Temperature is in Kelvin. That's 273. All right. So if you divide this, your value will go to 0.0821. Now the unit will be what? ATM. Then DMQ. Right? I want to write it out so that it will be in one line. So I'm going to have 0.0821 ATM DMQ mole per, because it's over mole, then Kelvin per. All right. So this will be the value of what? Of the ideal gas constant if the values of all these variables are what? ATM, DMQ, moles, and what? And Kelvin. So you have to be very, very, very careful so that you do not make any mistake. Now, what about if the value of what? P? If P is in Pascal now, for example, or Newton meter square, all right, and then volume is in meter cube, right? N remain moles, and then temperature is equal to what? Kelvin. So what of it if this is the case? P is now pressure is now in Pascal and not in what? In atmospheric pressure. It's not in ATM, right? Then volume is now in meter cube. Now R will still be what? R will still because of what? PV over what? Over NT. Just like in this case, we already know that 1 ATM is equals to what? 760 millimeter what? Mercury is equals to what? I've told you before. Go and check the previous video. We have done all this. Right? It's equals to what? 760 Thor. And then it's also equals to 101,325 Pascal. It's also equals to 101,325 Newton meter square. You must know this at the back of your head. You must know it, whether you like it or not. So please keep this at the back of your head. Now, this means that what? Our pressure is now in Pascal. So it will now carry 101,325 instead of what now? Instead of 1 ATM. So I'm going to have now pressure 101,325, then times volume. Our volume is 22.4 DMQ, but the unit here now is in what? It's in meter cube. So how do you now convert from meter cube to DMQ? In a previous video, I've told you also that what? Where should I write this now? That 1,000 mil is equals to 1,000 centimeter cube is equals to 1 DMQ is equals to 1 liter, and then it's equals to what? 10 to the power minus 3 meter. So if you know this conversion, if you know this at the back of your head also, then you can easily rather convert what? DM cube to what? To what now? To meter cube. That means it's between this and this. Since you know that what? 1 DM cube is equals to 10, that is this, it's equals to 10 to the power minus 3 meter, right? Then 22.4 dm cube will be equals to what now? X. So, right, if you do this very well, you see that what? That it will be equals to what? 2.24 times 10 to the power minus 2 meter cube. All right. So this value now is what I'm going to use here, right? Instead of what? 22.4 dm cube. All right. So please use that value. So I'm going to have 2.24 times 10 to the power minus 2 meter cube. Then all over, what is N? 1 mole. What is temperature? It does not change. 273. All right. So if you divide, I'm going to have 8.314. Now you're having 8.314, right? But the unit will be different from when you use what? ATM and what? And dm cube. So our unit will now be what? Pascal, PA. All right. Then volume, meter cube. Then mole per Kelvin per. All right. So let me write it out so that it will be very, very clear. Let me clean all this out. I'm taking all this out so that I'll write it out. I'll write the 2 unit out for you to see before what we proceed. Let's take the 2 units. All right. So the 2 unit is for R. R is what? 0.0821. If this is the what? If this is the value you're using, then the value will be in ATM, dm cube, mole per, and Kelvin per, right? Then if the value is what? If R is equal to 8.314, now it will now be in what? In Pascal, in what? Meter cube, right? In mole per, and what? Kelvin per. Or R will be equal to what? 8.314. Instead of Pascal, it can be what? Newton meter square, meter cube, mole per, and what? And Kelvin per. All right, so it's as simple as A, B, C. What I'm trying to tell you is that what? That the value of R depends on the value of the other 4 variables. Is that clear? All right, now that we have known this, I'm going to take an example. I'm going to take a question to see how we can what? Apply what? This knowledge to solve what? A problem. Now, the most important formula in this topic, of course, is PV equals to what? nRT. So now I'm going to make this part very fast so that we'll get the question on the board. The question was coined, of course, from the O3Schools JAMB CBT app. All right, this part is going to be fast now. All right, welcome back. Now, we are given a problem on the board, right? 350 centimeter cube of an ideal gas exerts a pressure of 1.05 atm at 37 degrees Celsius. What amount of gas is present? R is what? See the unit of R, atm, dm cube, mole per, Kelvin per, and 0.0821. All right, now solution, right? By giving volume is equals to 350 centimeter cube. Then by giving pressure equals to 1.05 atm. You know, in JAMB exam condition, you're not supposed to be writing this out. You are just write a formula out, but let's do it for sake of clarity. Then by giving R equals to 0.0821 atm dm cube mole per Kelvin per. All right. So now, so what do? We bring our formula. Our formula is what? PV is equal to what? nRT. And of course, what are we looking for? Amount of gas. We're looking for N. That means that N is equal to PV over RT. So before we can proceed with solving, our units are not in concordance, are not in concomitance for now, right? R is what? 0.0821 atm dm cube. Pressure is safe. We are safe with pressure here because the pressure is in atm. But the volume, we are not safe with it here because what? The volume here is in centimeter cube. This means we need to convert what? This centimeter cube to what? To dm cube so that it will what? It will coincide with this unit. Again, if we solve with centimeter cube, we will surely be wrong. And the answer will be there looking at us. You see it, you see the answer in the option. So you because you are in a hurry or because you have not known this, you just solve like that and you go and miss a simple question for not just any course, right? So now that we know what we know P, we know V, we know what R, we know what T. Temperature is what? 37 degrees Celsius, rather. T is what? 37 plus 273. You have to convert to Kelvin. This gives you 310 Kelvin. All right, so we know temperature, we know pressure, we know volume, we know molar gas constant, we know, we know ideal gas constant, and we know what temperature. So now what do? Convert this volume to dmq. How do you do that? Simply divide by what? By 1000. So 350 over what? 1000 will give us 0.35 dm cube. All right, so can I use this dm cube to what? To calculate? We can never use what? This centimeter cube because of this unit here. All right, so let's go. So n now, because what is pressure? 1.05. What is volume? 0.35. And of course, what is the R? 0.0821. Then times what is temperature? 310 Kelvin. So if we do the, are going to have 0.0144 Boyle. All right, so it's as simple as A, B, C. So please, you have to take note of your what? Of your units, of the unit of what? Of the ideal gas constant, so that you do not what? Make any mistake while solving. It's as simple as ABC, right? So that is the ideal gas equation. PV is equal to what? nRT. I'll see you in the next class.